Hello, am I audible, guys? Hello, am I audible, guys? Hello. Okay, so I'm Suvrat Mehta, and today we'll be discussing Code Forces Round 1043, Div 3. So let's start with the discussion. So, problem A. Vlad and Dima have been assigned a task in school for their English class. They were given two strings A and B and asked to append all characters from string B to string A in any order. The guys decided to divide the work between themselves and, after lengthy negotiations, determined who would add each character from string B to A. Due to his peculiarities, Vlad can only add characters to the beginning of the word, while Dima can only add them to the end. They add characters in the order they appear in string B. Your task is to determine what string Vlad and Dima will end up with. So basically, problem in problem A, we are given two strings, string A and B, and basically we need to append actually three strings A, B, and C. Append the characters of string B to string A. Also, uh, Vlad can add characters to the beginning of the word while Dima can add them to the end. So Vlad adds to the beginning and Dima adds to the end. Also, the characters are added in the order as they are in string B, and if the corresponding character in string C is V, then that means that character Vlad is adding, and if the corresponding character in C is D, that means Dima is adding. So let's see the test case. OT, AD, and DD. So A is OT, A is OT, B is AD, and DD. So basically, initially the string was OT, then the first character was added by Dima, so it will be added in the end. Then the next character is added by Vlad, so it will be added in the beginning. So the answer for this test case is Dota. Then A string is EFO, B string is RDCOECS, RDCOECS, and C is DVDVDVD, DVDVDVD. So basically, initially the string is EFO. Dima adds to the end, so R. Then Vlad adds to the beginning, so D. Then again end. Then again beginning. Then again end. Then beginning. Then again end. So Codeforces is the answer for this test case. So basically, to solve this problem, what we can do is maintain two strings, front and back. Basically, back representing the characters to be appended in the back, and appended at front. So we can iterate in the B array, in the C array actually, and if I is V, then basically we can add that character to the front array, and else we can add that character to the back array. So this will give us all the characters that needed to be pushed back, that are going at the back and that are going at the front. Also, since basically in this, for this test case, for back it would be R, C, then E and S. So R, C, E and S, and then front would be D, O, C. DOC. So DOC. As you can see that D was added here, then O and then C, and basically in our string FR they would be in reversed order because D was added first and then O was added and then C was added. So basically we can reverse the front string so that we'll get the characters in order as they are appended in the final string, and then our answer would be just F front plus A plus back. Plus is for concatenation. So we can do this in O of n since we are only iterating over the string C once, and FR and BA would also have O of n size, and reversing will be done in O of n, and concatenation will be also done in O of n. So overall solution is O of n. I'll show you guys the code. Basically string A and string B and C. And for FR we are pushing the characters BI, and when CI is D, then we are pushing it in the back array, and we are reversing the front array, and the final answer would be front plus A plus back. So that was the solution for question A. If you guys have any doubt, you can ask. A to E तक तो लिखा है, C1 power of 3 को max से min तक लिखा है. You guys can ask if you have any doubts in problem A. We'll be discussing till AB E, till AB C1 C2 D and E. So I think it is clear. Let's move on to the next problem. The secret number. Vadim has thought of a number x. To ensure that no one can guess it, he appended a positive number of zeros to the right of it, thus obtaining a new number y. However, as a precaution, Vadim decided to spread the number n equal to x plus y. Find all suitable x that Vadim could have thought of for the given n. Okay, and the constraints are t is less than equal to 1e4 and n is still 1e18. So expected time complexity would be log n or log n square something. Problem. So basically we were given an integer x, and then from x we created an integer y, which is basically all the digits of x and then some zeros appended at the end of it, and we are given an integer n, which is x plus y. So also the number of zeros is greater than equal to 1, since it is written that a positive number of zeros to the right of it. So number of zeros must be positive. So number of zeros should be greater than equal to 1. And we are given the integer n equal to x plus y. We need to find all the suitable x's. All the x which could have given this n. Find all x which could have given this n. So basically appending zeros in at the end of some number is basically just multiplying it by some power of 10. For example, let's say I had x is equal to 1012, and then y is equal to, let's say I take 1012,000. So y is nothing but 1012 into 1000. Uh, or y could have been anything. Y could have been this, or y could have been this, or anything. So basically, we can write a general form for y, which is y is equal to x into 10 to the power t, or 10 to the power k, where k is greater than equal to 1, since the number of zeros should be greater than equal to 1. Number of zeros appended should be greater than equal to 1. So y is x into 10 to the power k. So n is equal to x plus y. So n must be x plus x into 10 to the power k. So n must be x 1 plus 10 to the power k. And since x is an integer, n must be divisible by 1 plus 10 to the power k, because n upon 1 plus 10 to the power k is an integer. So to find the number of find all the possible x that could have been, we can simply iterate over 1 plus 10 to the power k and check if n percentage 1 plus 10 to the power k is 0 or not. If it is 0, then x has a possible answer of n upon 1 plus 10 to the power k. And we can loop over k from 1 to, let's say, 70, because n is till 18, right? So let's just do this. So this will be calculated in O of 18. So overall time complexity would be O of 18 into t. I'll show you guys the code. So I take input n, and answer vector will store all the different possible numbers that would be answer. And basically cur is my 10 to the power k, and while cur plus 1 is less than equal to n, so cur plus 1 is this quantity, while this quantity is less than equal to n, because since it is a factor of n, it must be less than equal to n. So while this is less than equal to n, n percentage cur plus 1 is, if n percentage cur plus 1 is 0, then I push back this possible value of x, and since we need to give answer in ascending order, I just sort, and then I output the vector. So that was the solution for question B. If anyone has any doubts, they can ask. N is equal to 1 plus 10 to the power k if n is given from the equation, find x. Yep. Time complexity, basically this loop will run a maximum of 18 times, since after 18 iterations curve would be 10 to the power 19, which will be obviously greater than n, because n is given less than equal to 10 to the power 19. So a maximum of 18 iterations can occur in this loop. And since we are sorting an array of 18 numbers, let's just also, actually it would be in descending order here, but that doesn't matter. This whole loop would be O of 18 something. So it's constant time. We are solving each test case in constant time. So you can either say O of 18, or you can say O of log n, or you can say O of 1, whatever you want. Yu multiple by 10. Basically, we need values of 1 plus 10 to the power k, right? So I initialize a variable with cur with initial value of 10, since k is greater than equal to 1, and then in each iteration I just multiply cur by 10. So cur becomes 100, then cur becomes 1000, and basically I'm checking if 1 plus cur, if n divides 1 plus cur or not. So this is the same as me checking n percentage 1 plus 10 to the power k. This I did the exact same thing, and the case for uh, where 18 nines that was going wrong. Uh, you might have a problem of overflow. I think you might have a problem of overflow if you did the exact same thing and you're getting wrong at the fourth test case. Expected rating of this question would be, I think, 900. 900, I think. See how to get to know we use the maths or the same algorithm or the sum algorithm. Um, uh, that comes with intuition. Um, that comes with intuition. That comes with practice. You start to guess what the question is demanding as you solve more and more questions. I also did long. Maybe in even in my case, I think it might go till 10 to the power 19. Uh, no, actually, it cannot, because even if car is 10 to the power 18, car plus 1 would be 10 to the power 18 plus 1. It shouldn't give long. Log base 2n or log base 10n. Since we are dividing by 10, multiplying by 10, so log base 10n. Can I share my code here so that you can check? Uh, you can DM me on Codeforces, or maybe ask in the comment section. I'll answer there. Right now, it would be a waste of for everyone. It would be a waste of everyone's time. You can ask in the comment section. I'll answer there. Okay, so I think you guys don't have any more doubts. Let's move on to the next question. Okay. So after the Cunning Seller sold three watermelons instead of one, he decided to increase his profit. Namely, he bought even more watermelons. Now he can sell 3 to the power x watermelons for 3 to the power x plus 1 plus x into 3 to the power x minus 1 coins. Okay, where x is a non-negative integer. Such a sale is called a deal. A calculating buyer came to him, but he has critically little time. Because of this, he wants to buy exactly n watermelons, making the least possible number of deals. So the buyer is in a hurry and has therefore turned to you to determine the minimum number of coins he must pay the seller for n watermelons, considering that he will make the least possible number of deals. So problem C. Basically, there is a shopkeeper who sells watermelon, and he sells 3 to the power x watermelon watermelons for a cost of 3 to the power x plus 1 plus x into 3 to the power x minus 1 cost. And where x is a non-negative integer, so x is greater than or equal to 0. Such a sale is called a deal, and a buyer wants to buy n watermelons in minimum number of deals, and we need to find the cost of doing so. So basically, let's just say that we do okay. Let's since n is 10 to the power 9, right? So let's say that 3 to the power 30, I think, will exceed 10 to the power 9. Let me just confirm because I checked in my code. Okay, so 3 to the power 30 exceeds 10 to the power 9, right? 10 to the power 9. So basically, for x greater than 30, there won't be any deals. We'll only do deals till x less than equal to 30, because x greater than 30 deals won't make any sense, because we only need to buy 10 to the power 9 watermelons, a maximum of 10 to the power 9 watermelons. So we'll only do deals till x less than equal to 30. So basically, now let's assume that I do a 30 deals of x to the power 30, 3 to the power 30, and then a 29 deals of 3 to the power 29, and a 28 deals of 3 to the power 28, till a 3 deals of 3 to the power 3, plus a2 deals of 3 to the power 2, plus a1 deals of 3 to the power 1, plus a0 deals of 3 to the power 0. And we need to minimize a30 plus a29 plus a28, so on till a0. So basically, since we need to minimize, right? So what we will do, our strategy would be basically, uh, if a28 is greater than equal to 3, let's say a28 is greater than equal to 3 in our current scenario. So what we can do is we can minus 3 from here and add 1 here. So that would progressively decrease our value. And if we reach a stage where there are no AIs which are greater than equal to 3, then that means that we cannot lower our cost further, lower the number of deals further. So that would be our most optimal distribution. So basically, if all AI are less than 3, then this means the distribution is optimal. So now what we can do is we can try to visualize this problem as a base 3 problem. Let's take some, also sum of this is equal to n actually. So let's take some n equal to 10 and try to find the base 3 representation of n equal to 10. So the process of finding the base 3 representation is let's just write this as a30 into 3 to the power 30 plus a29 into 3 to the power 29 till a0 into 3 to the power 0 equal to 10, right? So now I need to find this coefficient. What I can do is I can take mod 3 both sides. What this will do is for every term till a1, all those terms would be 0. And since in our optimal distribution AIs are always less than 3, so a0 cannot be a multiple of 3, since it can only be 0, 1 or 2. So this part would remain as a remainder. When we take modulo 3, this part would remain as a remainder, and all of this would go to 0, since all of them have a factor of 3. So basically, when I take mod 3, what happens is I get a0 into 3 to the power 0 equal to 10 mod 3, which is 1. So a0 is equal to 1. Now we need to find a1. So what we can do is basically divide this whole equation by 3, floor division by 3. So what happens when I do floor division by 3? Till let's do a2 3 square plus a1 3 plus a0 1. So if I do floor division by 3, all of these terms would give me an integer. So it would be actually let's just for now do normal division. We'll do floor after this. So it would become a30 into 3 to the power 29 plus a29 into 3 to the power 28 till a1 plus a0 upon 3. And all of these are in integer, and this is a fractional part. How this is a fractional part? Because a0 can only be 0, 1 or 2. So a0 upon 3 must be from 0 to 1. So this is a fractional part. And now if I take floor of this, basically doing the floor division, I would get a30 into 3 to the power 29 plus a29 into 3 to the power 28 till a1. And now again this is equal to floor division of 10 by 3, which is 3. And again if I take now modulo 3 on both sides, I will get a1 has a remainder here, and so a1 would be equal to 3 mod 3, which is 0. So a1 we have gotten as 0. Now to find the next element, what we can do is again take floor division. After the next floor division, we would have this number 28 plus a29 into 3 to the power 27 till a2, which is equal to 3. And if I okay, so this is after the floor division, 3 upon 3, which is 1. And if I take mod 3 on both sides again, so a2 I'll get as 1. And now if I perform further floor division, what I'll get is 3 to the power 27 plus a29 3 to the power 26 till a3 is equal to 1 upon 3, which is 0. And since sum of this is 0 and all ai belongs to 0, 1 or 2, then that means that all ai is equal to 0 from 30 to 3. So basically we have gotten our base 3 representation as let's start from the least significant bit. So a1 was a0 was 1, then a1 was 0, then a2 was 1. So 1 0 1, and rest are all zeros. And we can also check that this representation is correct, because we can put the value to go back to base 10, which would be 1 into 3 to the power 2. Basically this is the coefficient of 3 to the power 0, 3 to the power 1, 3 to the power 2 plus 3 to the power 1 into 0 plus 3 to the power 0 into 1. So this is 9 plus 1, which is equal to 10. So we see that in our base 3 representation matches exactly what we are trying to do in this problem. We are trying to minimize, we are trying to make sure that all ai are less than 3, so that there we cannot reduce the number of deals further. And our base 3 representation does the exact same thing. It basically gives us a representation like this, where all the AIs are less than 3. So for this problem, the solution would be, you can take n, you can go to the base 3 representation, and the base 3 representation would tell you what deals you need to make, and then you can sum the cost of those deals. You'll get the deals, and then we can sum. So let's try run this on some test case. Let's take n is equal to 10. N is equal to 20. Let's take that. So n is equal to 20. Let's try to find the base 3 representation. 1 2 3 4 5 6 7. So 20 mod 3 would give us 2. Then 20 mod 3 is 2. And then what we can do is 20 by 3, which is 6. 6 mod 3 is 0. And 6 mod 3 would give us 0, and then 6 upon 2, 6 upon 3 would give us 2. 2 mod 3 would give us 2, and then zeros. So we can verify also. This is 3 to the power 0, 3 to the power 1, 3 to the power 2. So 2 into 3 to the power 2 plus 0 into 3 to the power 1 plus 2 into 3 to the power 0 is nothing but 18 plus 2, which is 20. So this is the correct base 3 representation. So now I know that for 3 to the power 2 I am making 2 deals, and for 3 to the power 0 I am making 2 deals, and I cannot further reduce this number since we could have only reduced when this number was greater than 3 or any number was greater than 3. In that case uh, we could have moved forward to the next power of 3. So now let's find the answer. So 2 deals of 3 to the power 2 and 2 deals of 3 to the power 0. And what is the cost of each deal? The cost of each deal is 3 to the power x plus 1 plus x into 3 to the power x minus 1. So 3 to the power x plus 1 plus x into 3 to the power x minus 1. Let's put the value of x as 2. So 3 to the power 3 plus 2 into 3 to the power 1, which is 27 plus 6. 27 plus 6, 33, and into 2, since we are doing 2 deals, so 66 is the cost of this, and 2 deals of 3 to the power 0. So let's put x equal to 0. So 3, 0 plus 1 plus 0 equal to 3, and 2 deals of this would give us 6, and 66 plus 6 is equal to 72 would be our answer. So that was the solution for this question. Now let's analyze the time complexity. So we need to find the base 3 representation, right? So to find the base 3 representation, in each step we are doing a floor division by 3. So there can be a maximum of log base 3 n steps, and then maximum of log base 3 and number of different deals, and then again for summing we need to iterate over these. So we are solving each test case in a time complexity of log 3 n base 3. So that was the solution for this question. Let me show you guys the code. So basically I've defined a simple array with a name of p, which basically holds the powers of 3. Basically p of 0 is 3 to the power 0 and p of I is 3 to the power I. And then I've defined this function x function, which takes input x and returns the cost of 3 to the power x. So p 3 to the power x plus 1 plus x into 3 to the power x minus 1. And then I take input n, and answer is my answer, and x is basically this thing, the current coefficient, the current 3 to the power I am at while finding the base 3 representation. So basically initially x would be 0, which is this thing. So we'll get a0. A0 would be n modulo 3, and the number of this would be the cost. So n modulo 3 would be a0. This would be the cost. We can add that in answer, and then we can move on to the next bit. For next bit, we can divide n by floor division n by 3, and we can increase x by 1, and that would give us the answer. So that was for question C1. If you guys have any doubts, you can ask. Is there any easy way to solve this problem? I mean, this solution is pretty easy as well. I don't think it would be any easier than this. I got the part where AI belongs to 0 to 2, but what about the last coefficient A30? Can't it be more than 3? Is it because of constraints? The coefficient of A30 will actually be 0 because A30 is greater than 1E9, and we'll never do that deal because we need only until 10 to the power 9. So we need to only buy watermelons till 10 to the power 9. So why would we do a deal which buys us more than that? For C2, I applied Algebra. Can you please explain why did it TLE? ask any doubts for C1. Sir, who did not attempt it C1, they are unknown of questions also. Please make us understand. Did you understand, Deepak? What if n percentage 3 is equal to 0? Then that coefficient would be 0. Basically, this is very similar to how we find base 2 representations or binary representations. Is anyone understanding the question through? Um, uh, did I not explain the problem? The problem was basically you can do this deal. You can buy 3 to the power x watermelons for this cost, and in the question you need to buy n watermelons by using the minimum number of deals, and we need to find the cost of doing so. That was it for the question. Anyone has any doubts? Yes, instead of this, we can find the maximum x such that 3 to the power x is less than n and then proceed. Yes, you can do that. You can do that. Can we solve with ternary? Ternary what? Ternary search? Or ternary operator? What ternary? I didn't understand the deal part. Yes, instead of this, we can find the maximum x such that 3 to the power x is less than n and proceed. Yes, you can do that. Sir, I gave my first contest, solved the first and third and second got the compilation error. Is this good or bad? Well, it's your first contest, so it's good. I did this failed on 22509646. I can't debug everybody's code, guys. You can put that in the comments. Converting the number into ternary. Basically, base 3 is ternary. Ternary and binary are just names for base 3 and base 2. I did that. I just gave the proof of what happens. I just gave the proof of why actually you follow that process while converting to ternary or base 3. Please explain the deal part, bro. The question is still unclear. Can't just go with the solution. Okay, so basically, deal means what a deal means one transaction where the buyer buys 3 to the power x watermelons and pays 3 to the power x plus 1 plus x into 3 to the power x minus 1 points for that. This is one deal. One deal. So we can do as many deals like this as we want, but the question is that for minimum number of deals, how many coins do we need to pay? So we need to make sure that we are doing the minimum number of deals to get n watermelons. We need to buy a total of n watermelons, and in each deal we can buy 3 to the power x watermelons. And we need to minimize the number of deals that we are taking to buy n watermelons. and find out how many coins do we need to pay in that solution. Where did you understand now the question? Yeah, yes, there's another solution in the chat where he's saying that you can take the maximum power of 3 such that 3 to the power is less than 3 to the power n is less than num. So basically that's another way you can find the base 3 representation or ternary representation. Basically you can uh, find this power which is basically maximum power such that it is less than n. So this coefficient would be 1, 0, 1 or 2. It cannot be more than 3, since if it is more than 3 then the next power would also be less than n. So this would give us 0, 1 and 2, and then you can subtract this value from n and you will get the further coefficients. So that's another way of generating the term. Sir, I didn't understand the fun part in C1 problem. Fun is nothing. Fun is just a function which returns 3 to the power x plus 1 plus x into 3 to the power x minus 1. P of I basically is the value of 3 to the power I. P is nothing. P is just values of 3 to the power I. Basically, Pi is equal to Pi minus 1 into 3. And P0 is 1. P is just powers of 3, and fun just returns the cost of buying 3 to the power x melons, watermelons. So it is 3 to the power x plus 1 plus x into 3 to the power x minus 1. Fibonacci series. What does that have to do with this question? I'm confused in 3. Can you repeat? Which part are you confused in? Did you not get y base 3? Did you not get how to convert a number into base 3 representation or ternary representation? Or did you not get why converting into base 3 representation is the solution for this question? Which part did you not understand? Okay, thank you, sir. How can we improve this kind of logic? Just solve more problems. You can ask IIT KGB, you can tell which part you are confused in. Can you explain another approach for this question if possible? I do not know of any other approaches except for converting to the base 3 or ternary. There's different way of converting to the base 3 as well. Basically, what Ayush said, you can find the maximum power and then find its coefficient and then subtract that from it, and then you'll find the lesser powers after that. So you can do that. You can learn about how to convert any number in any base representations, and then it will be clear, I think. So let's move on to the next problem. Why in div 3 most questions we match? That is something I don't know. So C2. After the Cunning Seller sold 3 watermelons instead of 1, he decided to increase his profit. Namely, he bought even more watermelons. Now he can sell 3 to the power x watermelons for same points, where x is a non-negative integer. Such a sale is called a deal. calculating buyer came to him, but he has little time. So the buyer can make no more than K deals and plans to buy exactly n watermelons. The buyer is in a hurry and has therefore turned to you to determine the minimum number of points he must pay the seller for n watermelons if he makes no more than K deals. If it is impossible to buy exactly n watermelons while making no more than K deals, output -1. So basically problem C2. Again, the definition of deal remains the same. Uh, one deal is basically buying buying 3 to the power x watermelons for 3 to the power x plus 1 plus x into 3 to the power x minus 1 points. So this is the definition of one deal. It is the same as in last problem. Now what we need to do in this problem is make less than equal to k deals to buy n watermelons and find the minimum cost to do so. So basically, you can now do less than equal to k deals in this problem, and while doing less than equal to k deals, you need to buy n watermelons and find the minimum cost that you can manage to buy n watermelons for. So let's try to understand what exactly is going on in a deal. So let's take a deal where we buy 3 to the power x watermelons for 3 to the power x plus 1 plus x into 3 to the power x minus 1 points, right? So we bought 3 to the power x melons for these many points. So basically we are buying 1 melon for 3 to the power x plus 1 plus x into 3 to the power x minus 1 upon 3 to the power x coins. 1 melon for these many coins, right? So 1 melon for 3 to the power x plus 1 upon 3 to the power x would be 3. Then x into 3 to the power x minus 1 upon 3 to the power x would be 1 by 3. So we are buying 1 melon for 3 plus x by 3 points. So now what happens is we are paying more number of points to the shopkeeper as we are increasing x. So as we are increasing x of our deal, we are paying more points per watermelon. So this is the observation. So basically, we need to try and do deals with smaller x so that our overall cost would be lower, and we need to minimize our cost. So let's try to figure out what we can do. So basically, if we are doing one deal of 3 to the power x melons, right? Instead of this, what we can do is we can do 3 deals of 3 to the power x minus 1 melons. And here we'll have to pay 3 plus x by 3 coins per melon and here we'll only have to pay 3 plus x minus 1 upon 3 coins per million. So basically 3 plus x by 3 minus 1 by 3 coins. So this part is what we are saving if we are doing one deal of 3 to the power x millions. If instead of doing one deal of 3 to the power x millions, we do 3 deals of 3 to the power x minus 1 millions. So this is the part that we save per million. So let's actually calculate overall how much we saved. So we save 1 by 3 per million, and we are buying a total of 3 to the power x millions. So 3 to the power x upon 3 coins we have saved. And using the least number of coins is basically the same as maximizing the coins that we are saving. So 3 to the power x minus 1 coins we can save if instead of doing one deal of 3 to the power x millions, we do 3 deals of 3 to the power x minus 1 millions. So this is our next observation. So also by doing so, we require 2 more deals, because initially we were doing this in one deal, and then we were doing this in 3 deals. So 2 more deals we require if we are saving 3 to the power x minus 1 millions, 3 to the power x minus 1 points. So since we have only limited number of deals that we can do, we will first try to dissociate the higher powers of 3 into the lower powers of 3, because this is proportional to x, right? The higher the x, the more points we are saving. But for all x, we are taking one deal each, right? So it would be optimal to first transform the higher powers of x into lower powers of x. So what we can do is, let's now go on to some test case. Let's take 10 10. So 10 10, n equal to 10, k equal to 10. Let's try to extend our solution from the last problem. Okay, so for 10, what we did was one deal of 3 to the power 2 millions and one deal of 3 to the power 0 millions, right? So so now we have 8 more deals left that we could have done, because this is the minimum number of deals that we require. But since k is given as 10, we can do 8 more deals. So what we can do is, for this 3 to the power 2 million, we can make this 3 to the power 1 million deal. So now we will have 6 more deals left, and 1 3 to the power 0 millions. And now what we can do is, since we have 6 more deals left, we can dissociate, we can actually dissolve 3 more higher powers of 3. So since we have exactly 3 powers of 3 here, what we can do is transform this into 9 3 to the power 0 millions deal, and 1 we already had. So now we would have 0 more deals left. and we can now calculate the cost of this because we would have maximized our savings. So let's try some. Also, yeah, you can we can check the answer. So for 3 to the power 0 melons, we are paying 3 coins for each melon. So basically, total 10 melons and 3 coins for each, so 30. So we can 30. Let's try to solve this test case. 2014, n equal to 20 and k equal to 14. So 20 is basically 2 deals of 3 to the power 2 and 2 deals of 3 to the power 0. This is 9 into 2, 18 melons, and this is 2 melons. So after this was the minimum number of deals, so we would have 10 more deals left. So what we can do is first these 2 deals we can make them 6 deals. 6 deals of 3 to the power 1 million, and this would remain same, 2 deals of 3 to the power 0 million. So now we would have just 2 more deals left. Actually, sorry, 6 more deals left. So basically, for each deal that we transform into the lower power of x, we require 2 deals. So since we dissolved 2 3 to the power 2 million deals into 6 3 to the power 1 million deals, we required 2 extra deals for each this. So we required 4 extra deals. So 10 minus 4 is 6. So now since we have 6 more deals left, we can transform 3 of these. So what we can do is we'll keep 3 to the power 1 million deals, and we'll go 9 3 to the power 0 million deals, and we already had 2 3 to the power 0 million deals, and we would now have 0 more deals left. So this would be the last most optimal distribution that we can lead to, and for this we can calculate the cost. It would come out to be for 3 to the power 1, it would be 3 plus x by 3, right? So 3 plus 1 by 3 into 3 plus 3 plus 0 by 3 into 11. So this would be 9 plus 1, 10 plus 33, 43. The answer is 63. Just a second. 6 into 3, 18. 3 into 3, 9 plus 11. I think that is right. And 14 deals. 14 deals. 14 deals. 12, 13, 14. So 11 into 3, 33. And here is x plus, what was that? 3 plus x by 3. 3 plus x by 4 into 3. 30, 63. This is for a single deal. 3 to the power x plus 3 is cost of 1 million. And in one deal, we are buying 3 to the power 1 millions. And we are doing 3 deals of this. So 3 extra, 30 into 30, 63. You can also use that formula, this thing, 3 to the power x plus 1 plus x into 3 to the power x minus 1. So if we do that, 3 to the power 1 plus 1 plus 1 into 3 to the power 1 minus 1 into 3 plus 3 to the power 1 plus 0 into 11. So this is 9. 9 plus 1, 10, 10 into 3 plus 3 into 11, which is again 60. So let's take one last example. Let's take this minus 1 case, 1, 2, 3, 8, 3. So n equal to 8, k equal to 3. For n equal to 8, the base 3 representation would be 3, 2. Okay, so 2 into 3 to the power 1 and 2 into 3 to the power 0. This is 2 and this is 6, so it is 8. Okay, so since this is requiring a minimum of 4 deals and we were given k equal to 3, so answer is -1. So that was for this question. And now for to analyze the time complexity, since there are O of log n base 3 different deals that we would do at max. So and we would start from the most costly deal and try to dissolve it into the subsequent lower cost deals. And since we will only need to uh, move once through each of these log and base 3 different types of deals we need to do, so that would be the time complexity. I'll show you guys the code. For C2, basically this is the same code as C1, I think. Okay, uh, the change I made in this is now I'm storing the base 3 representation. Bit of I basically stores the corresponding AI coefficient for 3 to the power I, and that is n. So and k is basically the number of deals left after after doing the minimum number of, after doing the transaction in minimum number of deals left. So if k is negative after doing this in minimum number of deals, that means the answer is -1 because we cannot perform more deals than k. And now I'll count how much cost that I have reduced from what I initially had. So basically, if k is greater than 1 and we are doing deals for AI, then what we can do is we can reduce it by a number of times. Times is basically minimum of k by 2 and bit I. So bit I is the number of deals that we are doing for 3 to the power I, and k by 2 is the maximum number of reductions that we can do. Since each reduction takes 2 deals, uh, we require 2 deals for each reduction. So k by 2 is the maximum number of reductions that we can do, and bit I is the maximum, is the number of deals that we are currently doing for 3 to the power I. So and also we are looping this from the highest bit because that would be the most cost efficient. And taking the minimum is basically if uh, if k by 2 is lesser than bit I, then we cannot perform more than k by 2 reductions, right? So that in that case times will take the value of k by 2, or else if bit I is less than k by 2, then we can, in that case we can reduce all the deals. So in that case times will take the value of bit I, and then what we can do is reduce k by minus times into 2 and reduce bit I by times and increase the next deal with 3 into times, and this would reduce our cost by times into 3 to the power I minus 1, since we are saving 3 to the power I minus 1 coins in each reduction. So we are doing times number of reduction, and in each reduction we are saving 3 to the power I minus 1. So this much reduction we are doing. So answer minus reduction. And also if you don't want to do this answer minus reduction thing, you can basically again iterate over the bit array and calculate the total cost using the cost function, since bit I is currently storing the optimal distribution of deals. That was the solution for C2. If you guys have any doubt, you can ask. In C2, if you go by this method of making equations, then we'd want to minimize with the condition. Yep, yep. Exactly. Right, the base 3 and C, can we convert the highest or higher one to smaller? Yep, that is right. That is the approach for this problem. Sir, what should I do so that I'll be able to solve diff 2a and b and diff 3 abc easily? Just keep giving contests regularly and keep practicing. For the first time, I solved 5 questions. Can you please check for my submissions just once? Um, I'll do that in the comment section, please. Right now, I can't be checking everyone's submission. If someone has any doubt in this solution, they can ask. Rating for this C2, I think 1300, I think, or 1200. It might be more if, since it is maths, it can go maximum of 1500. I don't think more than that. Rating for C1, C1 would be, I think, 1200 or 1100. Maximum 1300, I think. Yes, I'll explain the fifth question in a minute. Okay, so let's move on to the next question. So, problem D. Vadim wants to understand the infinite sequence of digits that consists of the positive integers written consecutively from 1 to infinity. That is, in this sequence, that is, this sequence looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. To avoid looking into infinity, Vadim cut his sequence at the kth digit and discarded everything after it. Thus, exactly k digits remained in the sequence. Help him find the sum of the digits in the remaining sequence. So, basically, we are given an infinite sequence consisting of digits of the numbers from 1 to infinity. Basically, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and so on. And we are given k, where there are 2 into 10 to the power 4 test cases, and k is still 10 to the power 15. So uh, expected time complexity would be, I think, log k or something like that, not more than that. So we are given k and we need to find sum till k digits. For example, if k was given as 13, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We would have to find the sum of all these numbers, which would be 3, 6, 10, 15, 21, 28, 36, 45, 55, and 66. So that's what we need to do. And since k is so large, we can't simply iterate over the array. We would need to find some better optimal solution for this. So basically, the test case, solving the test cases would be like straightforward. So let's start discussing about the problem. So one thing that I can observe is the number of digits in the sequence till a number k increases with k. Basically, a very simple observation. I'm saying that as I actually k would be confusing with the input k, number x increases with x. So basically, what I'm saying is till some number x, the number of digits in this array would be um, would be equal to would increase with x. Basically, let's take x equal to 5 and x equal to 7. So number of digits in the array till x equal to 5 will be 1, 2, 3, 4, 5, which is 5 digits. And till x equal to 7, it would be 1, 2, 3, 4, 5, 6, 7, which would be 7 digits. So this is pretty obvious because when we take a higher number, all the digits till that lower number would also be present in the higher number. So the number of digits in the sequence till a number x increases with x. So what we can do is, since this is a monotonic function now, because it is an increasing function. So what we can try to do is try to find till which x number k digits are coming in the sequence. So we can use binary search for this. We'll see how we can write the function for binary search, but basically, since it is a monotonic function, so binary search can be used, right? So we can try to find the number x till which we will get the k digits. So basically, if we solve this problem, if we are able to solve this problem, then we'll have the new problem of finding sum of digits of all numbers till x. Basically, since we know that till number x k digits are occurring, like x is the first number where k digits are occurring, so sum of digits of all number till x would give us the answer. Basically, we'll need to adjust one sum of the digits of x because the sequence might not end perfectly at the end of a number. It might end at the middle of a number as well. So we'll have to adjust that, but we'll be able to pretty easily do that. So sum of digits of all number till x would be the next problem we'll have to solve if we solve this problem. So let's try to first solve this problem. So basically, if we want to apply binary search, we'll need to write a function which takes in the number x and returns numbers of number of digits till x, right? So if we manage to write this function, then we'll be able to solve the question. So let's try to calculate this. Let's try to find the number of digits till number some 327. So basically what we need to do is 1 2 3 4 5 6 7 8 9 10 11 12 13 all the way till 327 digits, all the way till 327. So what we can do is we can try to break down this problem. We can go digit by digit and we can do this number of one digit numbers into 1 and plus number of two digit numbers into 2 plus number of three digit numbers into 3, and we can so on do this. Basically, let's take for 327 what we can do is number of one digit numbers and number of two digit numbers and number of three digit numbers, right? Since we are taking all, since 327 is a three digit number, right? So we are taking all the one digit numbers. So number of one digit numbers would be equal to 9 into 1. And since 327 again is a three digit number, so we will be taking all the two digit numbers as well. So number of two digit numbers would be basically two digit number starts at 10 and then ends at 99. So number of numbers would be 99 minus 10 plus 1, which is 90. Also we can notice that for two digit it is 90. Let's find for three digit, it would be 100 to 999, which would be 899 900, and similarly for four digit we will get 9000. So this would be 9, this would be 90, and since now 327 is a three digit number, so not all three digit numbers are covered in this sequence, right? Only till 27, only from 100 till 327 we are covering. So what we can do is 327 minus 100 plus 1 into 3. Also here we'll get into 2. So we can break down a process in this way. So we'll be able to calculate the number of digits till a particular number in O of number of digits. And this is pretty straightforward of how you will do that, because let's take some bigger number. Let's take 5 6 7 4 3 2. So basically, since this is 1 2 3 4 5 6 digits, right? So all one digit numbers would be in this sequence. So 9 into 1. All the two digits would also be in this sequence. All the three digits would also be in this sequence. All the four digits would also be in this sequence, and 5 also. So all these numbers would be in this sequence. And now for the 6 digits, we'll have from 100000 to 567432. So what we can do is 567432 minus also into 2 into 3 into 4 into 5 minus 1 1 2 3 1 2 plus 1 into 6. So this way we can calculate the number of digits in O of number of digits. Number of digits till a certain number in O of number of digits. And then we can apply binary search on this value to find the exact number x till which we are getting the k digits. So now we will know that we need to now find the sum from 1 2 3 4 5 6 till x. Now our problem is this, sum of all numbers till x. Sum of digits of all numbers till x. So let's try to solve this now. Sum of digits of all numbers till x. Let's try to solve this. So first of all, do let me just do one thing. Let's try to find some patterns for this. So basically, let's take sum till let's take 9. So it would be 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7, 8, and 9. So this is 45, right? We all know that. Basically 9 into 9 plus 1 upon 2. So this is 45. Let's take now sum till 99. So what we can do is we can break down it like this: 10 plus 11 till 19, then 20 plus 21 till 30, and so on from 91 plus 92 till 99. So basically, let's try to look at this like this: 10 plus 1 plus 2 plus 3 till 9. Then we have 20 plus 1 plus 2 plus 3 till 9. And till 90 we have 1 plus 2 plus 3 till 9. So what this will do is we can see that this is 45, again this is 45, and this is 45. So 10 plus 20 plus 30 till 90 plus 45 into 9, right? And this is again 1 plus 2 plus 3 till 9 into 10. So 45 into 10 plus 45 into 9. So let's now try to find for sum till 999. Also, I forgot plus 1 to till 9. That will also have, so basically 45 into 10 here, since we have another 45. So 45 into 10, 45 into 10. Now let's try to find for sum till 999. So sum till 999 would also be something like this. Basically, we will take 1 and 1, and then all 2-digit numbers will come here. Basically from let me just write it actually: 100 till 199, then again from 200 till 299. So till 900 to 999, and also from 0 to 99. So we can bifurcate this like this: 0 plus 100 plus 100 into actually 100 plus 200 into 100 . Sorry, we are just counting the digits, right? Sorry. So basically 1 would come in 100 numbers, and 2 would come in 100 numbers. So what we can do is 0 into 100 plus 1 into 100 plus 2 into 100 till 9 into 100. And now for all we have sum till 99. So sum till 99 into 9 into 10. 1, 2, 3, 4 till 0 till 9, which is 10. So this and this above summation is basically 100 into 0 plus 1 plus 2 till 9, which is 100 into 45 plus 10 into sum till 99. So we kind of see a pattern. Similarly, for the last question also. We had this 45 into 10 one term, and then again 10 into 45. This is sum till 9. So sum, let me just write that equation. Sum till 99 is equal to 45 into 10 plus sum till 9 and into 10, I think, yeah, into 10. Then sum till 999 is equal to 45 into 100 plus sum till 99 into 10. And similarly, sum till 9999 would be 45 into 1000 plus sum till 999 into 10. Basically, you can see that you can again follow that same process. We'll go from 0 to 999, then from 1000 to 1999 until 899, 8000 to 899, sorry, 9000 till 9999. And then we can separately calculate for 3 digits and multiply that by 10. So sum of 999 into 10 plus, now we will have 1000 times, 2000 times till 9000 times. So 1 plus 2 till 9000 times. So this is 45 into 1000. So similarly, we get this relation. So I can write this as sum of 10 to the power d minus 1 is equal to sum of 10 to the power d minus 1 into 10 plus 45 into 10 to the power d minus 1. Basically, sum till 99999 is d is equal to 4. So is equal to sum till d3, which would be 1000 minus 1999 into 10 plus 45 into d3, which would be 1000. So you can see that. So this is our relation that we get, which would be very helpful in solving this problem. So let me write this in yellow. Sum till 10 to the power d minus 1 is equal to sum till 10 to the power d minus 1 into 10 plus 45 into 10 to the power d minus 1. So that's our current progress in solving the sum question. So now let's try to find the sum till some number. Let's take 5, 6, 7, 8, right? So now let's try to find this function for this number using this property that we just now discovered, right? So what we know is that this will have all numbers from 1, 2, 3 till 5, 6, 7, 8, right? So it will have all numbers from 0 to 999. It will have all numbers from 1000 to basically 1999. It will have all numbers from 2000 till 2999. So on till 4000 to 4999. And then it will only have from 5000 till 5, 6, 7, 8. So what we were doing above, we can try to follow the same tactic here. What we can do is we can separate the 0 to 999 sums everywhere. So for these 4, what we will get is sum till 999 into 4, and then I need to add for 1, 2, 3, 4. So plus 1 plus 2 plus 3 plus 4 into basically 1000, because 1 is occurring 1000 times, 2 is occurring 1000 times, and 3 and 4 are also occurring 1000 times. So we'll get this sum, right? But we cannot write the same for 5, because 5 does not occur 1000 times, and sum of this would not be sum of 999. So what we can do is we can do a kind of recurrence relation. So this plus this, and for this what we can do is plus 5 occurs 6, 7, 8 plus 1 times, right? because 5 is from 000 to 678. So 678 minus 000 plus 1, which would be 679 times. So 5 would occur this many times. And now what we can do is individually add sum of 678. So this term was for these, then this term was for the first number, first digit, and then this term was for the first digit of 5, first digit when first digit was equal to 5, and then this term would be for these. So these are just constant numbers, because sum 999 we already know from this recurrence relation. We can already calculate it of 1. I mean, we can pre-calculate it. So we can do this. And now for sum 678, again we can follow the same process. So sum 678, what we can do is 6 into sum till 99 plus 1 plus 2 plus 3 plus 4 plus 5 plus 5 into 100 plus 6 into 78 plus 1, and then again sum till 78. And for sum till 78, again we will get the same recurrence relation. 7 into sum till 9 plus 1 plus 2 till 6, then 7 into 8 plus 1, and then plus sum till 8. And for sum till 8, we can directly just do 8 into 9 upon 2. So we can use this recurrence relation to calculate the sum till sum of all numbers, sum of digits of all numbers till a certain number. And for sums till numbers like 99999, we can basically just recalculate them using this function. So, and also to get the x till where we need to find the sum, we can get that x by doing binary search. Basically, we try to find till which x numbers, k digits are coming in the sequence. So we can use binary search for that. So I'll show you guys the code now. And also for binary search, we have written a function that returns the number of digits till x, where we use this algorithm. So let me show you guys the code. So first of all is this digit count function. Digit count function is basically nothing but function that calculates the total number of digits till a certain number, comes in the sequence. So what we did was if the number was 6 digits, then from 1 to 5 we just basically multiplied this, and then for the 6th digit we did this. So here basically temp is the number of temp is actually the position where we are at currently. For first position, then the 10th position, then the 100th position, then the 1000, and the 10,000, and the 1 lakh. So basically this while loop is nothing but this thing. Firstly, temp would be equal to 1, and c is the number of digits. This temp is the number of zeros that would come, and 9 is basically for this. So initially temp would be 1, so 9 into 1 into 1. So initially in the first iteration I add 9, and then I multiply temp by 10, so that in the and increase c by 1, so that in the next iteration this becomes 90, and in the next it becomes 900, in the next it becomes 9000, and so on. And in the end, till whatever number we reach, basically temp would be this number. So we can subtract a minus temp and multiply it by c. So this would return the number of digits. And what we can do is basically apply a simple binary search. If digit count till mid value is less than n, that must mean that basically we will have a search space from L to R, and we'll take a mid value. If digit count till mid is less than n, then that must mean the x value is in this region. So what we can do is put our L here and reduce our search space by half. Or if the digit basically L equal to m id, and if digit count is greater than or equal to n, so in that case we set R as m. So R is mid, and this would give us the value. L is basically the x till which n digits occur. So what we can do is we can find the sum of digits till L minus 1, basically because we know that till x n digits are coming, so we can add the sum till x minus 1 digits, and then add whatever digits from the xth number that are remaining. I'll explain that in a moment. So let me just first explain how this function is working. So sum of digits, basically if n is less than 10, then I can simply do this, and d is nothing but count of digits. Basically I'm dividing by 10 and increasing d, so d is count of digits. Vector po is nothing but powers of 10. Basically I'm storing the powers of 10 so that I can, because I need them in the formula, in that reference. Here I need those powers. So powers of 10. Then a is basically this thing, sum till 999, sum till 10 to the power d minus 1 is vector LLA, and you can see that I have used this same relation. This, let's say this is a of d, so this would be a of d minus 1 into 10 plus 45 into 10 to the power d minus 1. So a of I equal to a of I minus 1 into 10 plus 45 into I minus 1 plus 45 into I minus 1. So this is nothing but this thing. And then what I am doing is MSD. MSD is basically for 5, 6, 7, 8. What I am doing is dividing 5, 6, 7, 8 is by 10 to the power d. D is the number of digits, so d would be 4. So dividing by 10 to the power 4, so this would give me 5. 5 is basically the most significant digit in this case. So from this 5 we know that here 4 will come, here till 4 will come, and here 5 will come. So what we can do is MSD into a of d minus 1, this thing, then this thing, sum till MSD minus 1, then into p is nothing but po into d minus po, 10 to the power d minus 1, and then MSD, then 1 plus n percentage p, basically 5, 6, 7, 8 percentage 1000. So this would give me 678. So 1 plus 678, 1 plus 678, and then plus sum of digits and percentage p. So plus sum of digits till 678. So this is how our recurrence function is working. So we know that till x n digits are coming, so we'll find the sum of digits till L minus 1, and we can count how many digits are coming till, count the number of digits till the number L, and if we subtract L from n, then we will know how many digits we need to take from L, because we have summed till L minus 1 and there might be some leftover digits that we need to take from L. So we can do that here, and we will add the number of whatever digits we need to add from L, and then we will get our answer. So that was the solution for the fifth problem. Did you guys understand this? Um, if you guys have any doubts, you can ask. So I think you guys don't have any doubts. So let's move on to problem E. So E is arithmetics competition. In the arithmetic competition, participants need to achieve the highest possible sum from the cards they have. In the team, FST Ezik Vadim has N cards with numbers AI and Kostya has M cards with numbers BI. In each of the Q rounds, they want to win, but this time the rules of the competition are slightly different from the usual ones. In each round, the participants are given three numbers X, Y, and Z. The team FSG ASIC must choose exactly ZI cards from all the cards they have, but Vadim can choose no more than XI cards from his set, and Kostya can choose no more than YI cards from his set. Help them find the highest possible sum for each of the Q rounds. So now constraints are sum of n and m are till 2e5 and queries are also till 1e5. So we'll need to answer queries in O of log n something, and we need to solve the question in maximum O of n pre-computation before queries. So let me explain the question first. Also, let me fix the question. So basically, we have Vadim and Kostya. Um, problem E. Vadim and Kostya have some cards. Vadim have A1, A2, A3 till AN, and Kostya have B1, B2, B3 till BM. And then in a query, we are given X, Y, and Z, and what we need to do is select Z cards uh, from Vadim and Kostya, such that let's just say that we select A cards from Vadim and B cards from Kostya. So basically A cards from Vadim and B cards from Kostya. So we have these constraints. A must be less than or equal to X, and B must be less than or equal to Y, and Z must be less than or equal Z must be equal to A plus B. So we have these three constraints, and we need to maximize the sum of all the cards. Maximize the sum of all the cards. So let's try to solve the questions, because test case I don't think would help much right now. So first observation, for the A cards, Vadim is choosing they must be they must have the they must be the highest value cards. Basically, if Vadim had let's say 1, 2, 7, 3, 4, 9, 11, and he had to choose, and let's say A was equal to 3, then he would obviously choose the top 3 highest cards, right? And similar same for Kostya. So basically, we will always choose the highest cards that are in our deck. So basic because we want to maximize the sum, so there is no point in choosing the lower value cards. So this is our first observation, pretty obvious. Now this tells us that we need to sort the array, sort and reverse the array. Because then all the high value cards will be in the front. So now let's try to answer the question kind of naively, not focusing on the not focusing on the time complexity. Let's just try to answer it. So basically, what we can do is, since we need to select k cards, so what we can do is we can either select Vadium, Kostya. We can either select 0 from Vadium or 1 from Vadium or 2 from Vadium till k, and actually not till k, till a x, and similarly corresponding to 0 we'll select k from Kostya, k minus 1 from Kostya, k minus 2 from Kostya till k minus x, and also not from k, actually from y. Somewhere here y will come, and from there we can choose. So basically these are all the possible combinations that we can choose, right? So let's just define the range actually. So we can select a maximum of let's not define the range. So basically how can we solve this naively? We can compare for each value and select the maximum out of these, right? So how can we compare? Let's just use prefix sums, because it is obvious, since we need to select 1, 2, 3 till x cards from Vadium. So it would be easier if we sort, then reverse, and then take prefix sum. So for PA, I will be using to denote the prefix sum for Vadium, and PB I will be using to denote the prefix sum for Kostya. So what we are trying to do is trying to find the maximum of PA of I plus PB of k minus I. Right, we are trying to maximize this. Also, we have some constraints. I must be less than equal to x, and k minus I must. Currently, I am talking all in one based. It would be pretty simple to go from one base to zero base. We'll do that in code, but yeah, all this is in one base. So PA of I and plus PB of k minus I. And the constraints that we have is I must be less than and equal to x, and k minus I must be less than and equal to y. Right, and already I plus k minus I is equal to k. So the sum of both the Vadim and Kostya is equal to k, but we need to make sure these constraints. So I must be less than and equal to x, and I must be greater than and equal to k minus y. So what we can do is maximum of I equal to k minus y till I equal to x, PA of I plus PB of k minus I. Right. So to solve this as it is, we will require O of n complexity for answering the queries, but we cannot perform O of n query, O of n time complexity for each query. So let's try to optimize this. Let's try to understand what kind of function this is. So let's first do analysis for PA. So PA is a reversed is prefix sum of a reverse sorted array. Right. So basically, reverse sorted array would, let's take an example, 10, 7, 6, 3, 2, 1. So prefix sum of this would be 10, 17, 23, 26, 28, 29. Okay. So, so first of all, this function will be always increasing since all the numbers are positive. So this function would be always increasing. So f dash of PA would be positive, right? Now let's try to check the concavity of this function. So basically, the function would be increasing, right? But the rate at which it increased, here it was increased by 7, here it is increased by 6, here it was increased by only 3, here it was increased by 2, here it was increased by 1. So basically this increase is the slope, and slope is decreasing. Slope is always decreasing. So f double dash of PA would be negative. We can also try to plot this. So 10 would come here, 17 would come here, then 23, then 26, then 28, and 29. So this function would look like this. It would be increasing. It would be increasing, but it would flatten as it goes on. So these types of functions have double derivative negative, since the slope at which it is increasing is decreasing. So now let's try to see for PB of k minus I. Right. Again, let's take some example. Let's take the same example, 10, 7, 6, 3, 2, 1. And let's take the prefix sum 10, 17, 23, 26, 28, 29. So now for I equal to 0, actually our function is from here to here. So let's try to plot this. 28, 29, then 26, 23, and 17. So first of all, this function is decreasing, right? Minus 1, minus 2, and then minus 3, then minus 6, and then minus 7. So this function is decreasing. So f dash of PB is negative. And the slope, the value of slope, minus 1, minus 2, the value of slope is also decreasing in each consecutive step. So for value of slope to also decrease, double derivative of slope must be negative. Derivative of slope must be negative. So again, f double dash of PB would be negative. And we can see that in the graph as well, that initially the value would be high, but as we go on, the rate at which the value decreases would increase. So it would look like this. The rate at which the value would increase, 28, 29, 28, 26, then 23, then 17, then 10. So the rate at which the value is increasing the rate at which value decreasing would increase. So these and this function have basically the same concavity, and it is double derivative is negative. double derivative is negative. So basically we now know that PA of I plus PB of k minus I, since this function and this function both are double derivative negative, this whole function would have a double derivative negative. So what does this mean? Double derivative is negative, so that means the function must always look like this. So for functions like this, we can use ternary search to find the maximum. Now what is ternary search? Basically we have some search space for I. Basically let's say I starts from I naught and I ends till IF. So in this search space somewhere there is a maximum and we need to find it, right? So how ternary search works is, basically I'll divide this in 3. Here it would be I naught plus IF minus I naught upon 3, and here it would be I naught plus 2 upon 3 IF minus I naught. Basically I have divided this region into 3 equal parts, and then I can find the value of the function at these 2 parts. Right now, since this value is smaller than this value, right, this value is smaller than this value, then I know that my maxima must be somewhere here. My maximum must be somewhere here, because this second mid could also have been here. So then maxima would be behind second mid. So maxima could be anywhere in this region. So what I can do is I can reduce my search space to this, and then keep applying the same operation. This is known as M1 and M2, and so if we keep applying the same operation, we will get this point, and this point would be the maxima of our function that we need to find in this question. Also, we will need to acknowledge these constraints for the search space. So the ternary search, since it basically reduces the search space. If the region was R initially, then it reduces it by 2 by 3R. So it would again take at max log n steps. And prefix sum calculation is prefix sum would be calculated outside of the queries, so that would be O of n plus m, and queries would be answered in log n, because finding the maxima would be answering the query. So overall time complexity would be O of n plus m plus q log n. Also, I'll show you guys the code now. I've written the code in 0 base, so there might be little differences in functions, but it does the same thing. So basically input nm, input ab, then sorting ab, and then reversing ab's, and then taking the prefix sum pa and pb. Then basically this is my that epsilon is not needed. This is my logic for ternary search. Basically M1 and M2, then the value at M1 and the value at M2. I'll show you guys the function as well. So if F1 is less than F2, basically if this point is less than this point, so what I can do is this was if F2 is less than F1. If F2 is less than F1, then R equal to M2, or if F1 is less than F2, then basically it would have been this case. So in this case we'll move the L. L is equal to M1. So I have this, and what I have done is I have reduced the search space till R minus L is greater than 5, till r minus l would be less than equal to 5, and then I can individually check for all the points to find which point has the maximum. Basically, I have taken cur as 0, and then for each from I and to r, I have checked if the value at this point is greater than cur. Then I have set cur to that value and index I. So index I would hold the maximum value. And here some edge cases that I had difficulty covering with zero base, so I had to like write them separately. Basically, this and this is for the case when I am taking 0 from A and all the Z items from B, and this is for when I am taking 0 from B and all the Z items from A. So these two are those cases. Let me show you guys the function as well. Also, the search space would be from x minus 1 till z minus y minus 1. We have seen this. Basically, this k is z. So z minus y minus 1 till x. Basically, this was a one base. So that yes. So this and function is nothing but just selecting I from the PA and Z minus I from PB. And this basically because of one based, I had to, because of zero based, I had to write especially for -1 indexes. So it would have been much better if I had written in one based. So yes, that was the code for this question. That was the solution for it. So if you guys have any doubts, you can ask. So I think you guys don't have any doubts. So that was it for today's discussion. I'll end the stream now. Thank you.